Today we're going to cover section 4, and we're going to learn how to use inscribed angles and inscribed polygons. So the first thing we have to do is define what an inscribed angle is. So an inscribed angle is an angle whose vertex is on a circle and whose sides contain chords of the circle. So prior to this, we learned about central angles. And if you recall, a central angle has its vertex at the center. So the difference between a central angle and an inscribed angle is the central angle, the vertex at the center, but the inscribed angle, its vertex is sitting over on the side. And the sides of this inscribed angle, they contain chords. If I were to keep going and turn these into lines, then they would be secants. But just know the sides of the inscribed angle within the circle, these are chords. The next slide has a theorem that describes how to find the measure of either the inscribed angle or its intercepted arc. So the measure of the inscribed angle is 1/2 the measure of its intercepted arc. So I will show you what this means. Now, also, if you recall, the central angle equaled the arc measure. This time, the angle measure will be 1/2 of the arc. So for example, if I told you arc AC was 40, then that would tell you the measure of angle ABC here would be 1/2 of that, and it could be 20 degrees. Or if they give you the angle, so let's say I draw another circle here, and let's say I draw an inscribed angle here. And let's say this time I gave you the angle measure first, and I told you it was 30. To find its intercepted arc, times it by 2, and the arc measure would be 60. So know how to find an angle measure given an arc or vice versa. Theorem 10.8 states, if two inscribed angles of a circle intercept the same arc, then the angles are congruent. So for example, if I trace over angle 1, notice its intercepted arc is arc AB. But if I trace over angle 2, notice the endpoints here, it also shares arc AB. So when they have the same intercepted arc, then that tells you that angle 1 is congruent to angle 2. The two angles are congruent. Next, we have the definition of inscribed and circumscribed. So an inscribed polygon is a polygon with all of its vertices on a circle. So we could say that the polygon is inside the circle. So inscribed, inside. A circumscribed circle is a circle that contains the vertices of an inscribed polygon. So here we could also state that the circle is circumscribed about the triangle, if I was referring to this picture. If I wanted to say the circle is circumscribed about the, and instead say quadrilateral, then I'm referring to this picture. So that's how you would phrase using those words. Next, Theorem 9. Here we go with the word inscribed. So it says, if a triangle is inscribed in a circle, so we have a right triangle and it's inside the circle, then the hypotenuse is the diameter of the circle. Conversely, if one side of an inscribed triangle is a diameter of the circle, then the triangle is a right triangle. And the angle opposite the diameter is the right angle. So notice when they've written it down here, they're using the words if and only if. So this is why they're first giving us the theorem and its converse, because we could say it either way because of the words if and only if. So if you notice in your picture here, notice we have a diameter here. So we can see that we have a semicircle arc. This would be 180. Making this half of that 180, which would make it 90 degrees. Theorem 1010 states a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. So what this states is if angle 1 plus angle 4 equals 180, then I know that these are supplements, and then the same thing here. This plus this needs to equal 180. So if those opposite angles are supplements, then I know that quadrilateral is inscribed. So what may happen is they might give you a question and they might say, quadrilateral ABCD is inscribed. Find the measure of angle 4. So if you know that it's inscribed in the circle, and let's say they told you angle A was 110, then that should tell you that 2 plus 4 is 180. So to find angle 4, or C that I've labeled here, subtract it. And angle 4, or angle C, could be 70 degrees. So realize that when your quadrilateral is inscribed, opposite angles will be supplements. Now, notice this theorem only states that a quadrilateral. It doesn't specify if it's a square or a rectangle. It's just a quadrilateral. Now, if you have a square inscribed in a circle, obviously both angles, all angles would be 90, so opposite angles would be supplements. Useful fact number 1, an angle inscribed in a semicircle is a right angle. So notice this angle 1 is an inscribed angle. It's sitting on the side, and because it's inscribed in a semicircle, I know it's a right angle. Because again, remember this arc measure is a semicircle arc. It's 180, and then the inscribed angle is half of that. So then I know it's 90 degrees, making it a right angle. So this is just a useful fact that you'll probably be using quite often to solve problems. It was based off the prior theorems that we saw. Use fact number 2. The measure of an angle formed by a chord, so here is my chord, and a tangent is equal to half the measure of the intercepted arc. So this angle 1 would be half of its arc measure. So for example, if I told you its arc measure is 130, then that tells me that angle 1 would equal half of that, which is 65 degrees. Now, let's say I put a little 2 here, and I said, find this measure. So to do this one, there's several things I can do here. I could realize that 1 and 2 together are sitting on a straight line. That's probably the easiest way. So subtract it from 180. And I can find out that the measure of angle 2 equals 115. The other way would be to find the arc measure. So I could find this arc measure by subtracting 360 minus the other arc that I have. And this arc would be 230, and then divide it by 2, which gives me the 115. Either way. So a lot of these problems have multiple ways of getting to the answer. Let's try to apply all of these theorems. So let's zoom in on the first example. So this is circle O. That's what they called it. And they want us to find x and y. So first thing I'm going to find is x. So if I trace across the angle that's forming arc x, we can see the angle measure is 20. And the very first theorem we learned was when we have an inscribed angle, its arc measure would be twice as big. So x would be 2 times 20, and it's 40 degrees. Now, angle y here is this whole thing right here. So probably the easiest way to find its angle measure is to figure out what its arc measure is. So notice if I trace over the angle, the arc measure goes from here over to here. So 110 plus 40. So that entire arc for angle y is 150. And then to find the angle measure, divide that by 2. And angle y equals 75. Now, other ways you could go about doing this is you could realize that angle y is actually made up of this piece and this piece. So you could have found half of 110 and got 55, half of 40 and got 20, and then added 55 plus 20 and got 75 that way also. So either way, x is going to be 40 and y is 75.
Wait, but why is y 45? I thought it was the, like,
As y is this whole thing. So it's,
okay.
yeah, so it's the whole thing. I know sometimes it's hard to tell what it's pointing to, but it's actually pointing to both pieces together. Okay, so for this one, first thing I'm going to do is figure out, let me trace over and find the arc for the angle that I have. So here is my angle, that's 20. So then I know its intercepted arc will be double that, so it'll be 40. And then notice x is the same, it's using the same arc. So this is that theorem that states that if they share the same intercepted arc, then the angles are congruent. So this tells me that x is also 20 degrees. And now to find y, I can realize that I have a semicircle right here. So I have a diameter. So this is going to be 180. So when you have a triangle that's inscribed in a semicircle, this angle here is a right angle. So y equals 90 degrees, or half of the 180. Because notice the endpoints of angle y are the diameter. Okay, this is going to use that useful fact that when you have a chord and a tangent line, this angle is half of its intercepted arc. And then the same thing on the other side. So what I can do is trace over the 60. So its intercepted arc, which is right here, is 120. So again, the angle formed from the chord and the line tangent will be half of the intercepted arc, So x equals 60. Now I know this picture is a little misleading. It looks like these are congruency marks, but I'm going to add a little tick mark here because x and y are not congruent. All right, so now to find y, I can do several things here. I could either realize that this part right here, this is its intercepted arc, which is 140. So this tells me that this is 70. So then these three pieces right here are sitting on a straight line. So I could add 70 and 60, subtract from 180, and I could find y to be 50. Or I could also add these arcs, 140 plus 120, subtract from 360, and now this arc over here, what was remaining, is 100, and then y is half of that. So that's why it's 50. So y equals 50, and x equals 60. All right, so in figure D, notice I have the arc measure for angle X, and it's 80 degrees. So this tells me that X is going to be half of that, and it's 40 degrees. Also realize that this is a diameter, so this would be a semicircle arc. And then from here, we can also look for some other things. We could realize that what we have here, when you have a triangle inscribed in a semicircle, then this would be a right angle, making this 50 degrees, which would make its intercepted arc 100. And then from there, same scenario here, we could also see that when you have congruent chords, you have congruent arcs. So then here, this would be 100. So then this would be 50 degrees. So y is 50. So we're given that circle O is congruent to circle P and arc AC is congruent to arc AB. They want us to prove that the two triangles that are inscribed are congruent. So the first thing I'm going to do is write down my given. So statements and reasons. So number one, I'm going to say that circle P equals circle O, or is congruent, and that arc AC is congruent to arc AB, and that was given to me. Next, I'm going to realize that I have congruent circles. So by definition of congruent circles, I could state that DO is congruent to AO, and AP is congruent to EP. And this is by definition of congruent circles. So that's going to make this leg, or this piece, congruent to this. Next, I'm going to bring in my arc measure that I already know is congruent. So I know that this arc is congruent to this arc. So I'm going to bring in that this angle, CEA and BDA, are going to be congruent, but I'm going to first show what they're made up of. So angle CEA is equal to half the measure of arc AC. And angle BDA is equal to half arc AB. And this is inscribed angles equal half the arc measure. That's your second theorem or second thing that we saw. That was the first theorem, 10.7. Next, what I'm going to do is I'm going to do substitution. Since I already know that these two are congruent, I'm now going to say that angle CEA is equal to 1/2 AB. So this would be substitution. And now I'm going to do substitution again and say that angle CEA is congruent to angle BDA, which will be substitution again. Next thing I'm going to do is try to get another piece congruent. Notice I've got triangles inscribed in a semicircle. So my next statement is going to be angle B equals 90 and angle C equals 90. And that reason is if an angle is inscribed in a diameter then the angle equals 90, or it's a right angle. So now I can do substitution and say angle B is congruent to angle C, substitution, and now I have enough information. So now I have the right angles marked, and I also have the angle marked. So now I can say that these triangles are congruent. Triangle ABD is congruent to triangle ACE, and my reason is angle, angle, side. Okay, so that is the last example. Your homework is 10.4. You have around 20 minutes to work on it, and that's it.